In the next video in the water series, I will show how to create an advanced fish AI. This first part will cover passive fish. Here is some koi fish in this Japanese-style garden pond which are swimming around. You can make any type of fish from small ones like trouts to large ones like whales. These passive fish will roam and interact but will not attack others. Pathfinding is used so the fish simulate swimming behavior realistically. The video will show in more detail how everything is set up, and it is made easier with a fish spawner so you don't have to manually place all. There are two types of patrolling, with the first being randomly in the bounding area. These fish will go to a random position inside this pool, then wait a random set time before roaming again. The second is patrolling within range. This will find a location around the current fish position as the new one and is bounded by the area. I will turn on debug to showcase the pathfinding and destinations. This is the pathfinding grid and the fish will find points in it to travel using. The fish has energy and will sleep once depleted. They will rotate when sleeping while the energy is restored back. The fish can also die. They can sink or rise on death, although the tutorial only covers rising. The koi will rise until they reach the water surface, at which point buoyancy is used to let them float. They can be set to pushable if you want to. The fish have sight and hearing AI perception, which can be set to different levels of ranges. These fish are set to follow the player and noises. They are following the player, but to make it more realistic they will randomly swim away instead of just staying by the player's side. These new fish are set to flee instead. The random factor is increased here, but they will flee the player and noises by trying to swim in the opposite direction. The fish can also interact with submarines, which I made earlier in the water series, but it is not required to follow along this tutorial. There are many other smaller details and features which will be shown in the tutorial. You can easily make any type of fish using 3 main blueprints. The level setup is also fairly simple. The tutorial also covers a fish spawner actor which will randomly spawn the selected fish around the area. If you purchase the project files, there are many exclusives starting with a random color and hue multiplier, so the fish are not all identical. Here the koi also use a random texture for variance. I set the hue variance to a higher range for showcase purposes for these fish, and it will be random each time. Also included is extra death options such as whether it rotates or not. Also the fish can have Ragdoll enabled as an optional setting on death so it realistically flops. The squid is different as it just floats in place instead of sinking or rising. It might not be scientifically accurate but is just for showcase. A variety of extra fish examples templates are also provided, starting with this whitefish. Next is this Dace. Next are trouts. There are 3 variants for trouts and it will randomly select one on start. Here they are in a realistic Viking map environment. Next are tuna fish, which is a bit larger. These are Manta Rays. They are passive as they will not attack, unlike stingrays which will be added in the predator fish video. Next are seals. These have an option toggled to make them have to surface to breathe, as you can see. Seals also collide with the player since they are larger. Here are squids. These have the option to shoot ink, as you can see. The particle is a simple placeholder one and the mechanic will be added upon in the next video, so they shoot ink at predators. Finally is a blue whale. This will need a large open space to swim around in due to its size. Also the swimming is made faster just to keep up with the whale to showcase. The player collides with the whale and it will also push them if in the way. Like seals, whales will also need to surface to breathe, at which point it will also shoot water from its blowhole. Again, the particle is just a placeholder to show how it works, since I am not a VFX specialist. Submarines will collide with the whale and smaller ones will actually be pushed by the whale, such as when the tail hits it. Large submarines like this will collide with the whale but won't get pushed by it like the small one did. The fish spawner has some extra features in the project files, which includes being able to add multiple different types of fish with a single spawner and choosing if they are distributed equally or not. Here is a map with a lot of fish, both as Niagara particles from the School of Fish video and AI fish actors which were spawned. The fish are all highly customizable, as you can see here, with options to make them however you want. This video again is only for passive fish, and the next one will cover predator fish such as sharks. Before we start, there are some disclaimers. First, this is more of a framework since it uses a plugin and it isn't grounded AI, so the behavior tree may not be the most optimized in regards to this. There may be some bugs and the fish isn't that smooth, but it is the best I could do with the plugin and methods used. Second, event tick is used, so it will be performance heavy, especially if you have a large number of fish. I showed an alternative method to avoid this by using timers, but you can also try pausing and starting tick only when the camera or player is in view of the fish. Third, if you are planning to make many different types of fishes, you will need to import and set up the blend space, dead fish actor, etc., since most fish will use different skeletons and models. Fourth, while I tried to optimize the code as much as possible and employ good programming practices, it did become very complex at times, and since this is my first time using behavior trees, the methods used might not be 100% perfect. This is a minor issue, as things like hard casting and performance affecting code is done very little. Fifth, the video structure may not be the best, especially for beginners, as I basically just go through recreating the code which I have already made and tested. This means that I can't easily show the functionality of each stage in game since I work on it from the ground up, so all events, functions, etc. are made then compiled together. This is done since it will be time consuming to break the systems back into self-contained chunks due to how large it is. Sixth, the fish are not scientifically or biologically accurate. Only to some extent in regards to their behavior. This video features the swimming mechanic I made from a previous video, although it is not required to follow along for most of the AI. Submarine interaction is also added here, again not required to make just the fish AI. Finally, I have showed how to make school of fish using Niagara if you are looking for a more simple and direct approach for scattering fish around a level. The links to all will be in the description. First are the prerequisites. I have this Japanese style garden map I made, and it uses the water plugin by Epic. You can use any other plugin or water approach you want, as it doesn't impact the AI. First, open your character blueprint and ask an AI perception stimuli source so AI can detect the player. Check the auto register as source checkbox. Then add an element and set it to AI sight sense so the fish can see the player. If you have the swimming, go to the interaction part here and copy the code to make an AI detectable noise when swimming. Reduce the noise as it was too loud. Next, if you have submarines, open it and go to the submarine timer code. Add a noise here too with a delay, and if the normalized speed is high enough. We need to get a plugin now. It is this free customizable pathfinding one by non-static, which I will link in the description. If you want more details on it and how it works, I will link this documentation of it as well, which you can read through. Install and enable it, then restart the engine. We will first set it up in our level. Select your landscape or area where the fish will swim in and add a tag called landscape. Then in the content browser settings, enable show plugin content. Find the C pathfinding content folder. In blueprints, there is a BPC path volume actor which we will use. Add it to the world. This water level variable needs to be set to the Z position of the water surface, which is 0 for me. Now you need to move and scale the actor so it encompasses the whole water volume. The top of the box should be just under the water. There are many settings here and you can hover over the variables to read what exactly they do. The important ones are voxel size, which is the grid size. For a small pond like this, a size of something between 50 and 150 works well. The octree depth you can set to either 2 or 3, which is suited for empty areas of water like this. In render, enable draw occupied. Now add a trigger box to the scene. Again move and scale this to fit the water volume area. This is the box that will be used to calculate a random move to position from. Use the box extent to scale it instead of the actual scale option. I will move the 2 to a new folder. Now I will start the fish mechanics. First you need a model. While you can realistically use static meshes for this, I am specifically making it for skeletal with animations. I will use this koi model by this user from Sketchfab, but you can use any. I have already imported it in Engine with the materials applied. Open the mesh, then add a socket to the tail called tail socket. Then click on make static mesh at the top and add one. Open it and add 26 DOP simplified collision to it, which is the most complex one. This one has these animations, but you can make it with just one animation and changing the play rates. Right click and add a blend space 1D, choosing the fish skeleton. Set the axis name to speed with a minute and max value of 0 and 2. Set the smoothing time to 0.2 and weight speed to 2 so the transition is smooth. Also set the grid divisions to 2. Add idle at 0, regular swim at 1 and fast swim at 2. Hold shift to snap to the grid. Next make a new folder for the enumerations. Enums are basically a way of storing and reading a variable with a set of names we give so it is easy to understand for the programmer. First will be one called AI perception type and will have 3 values which are close, medium, and far. Next is detected hearing, which will have none and heard. Then make one called detected sight priority with values of none, player, and predator. Next is patrol state and will have values of waiting, roaming and fleeing. Then make one called patrol type. It will have values of random in bounding area and random in range. Next is player interaction type with values of none, follow and flee. Finally is sleep type with values of side and default. The purposes of these will be explained when used in the actual code. In the main folder make an enum called fish type with values of passive and predator. Predator fish will be covered in the next video and will have all the features that passive ones do, but with extras such as chasing and attacking other fish lower in the food chain. Now make an enum called fish species. This will act as the food chain and you should add all your fish to this in order of lowest to highest, so something like koi would be below something like a shark. Now make a blueprint interface for the fish. The first function will be called getPatrol position with a vector output. I will also categorize them into folders. Next is set patrol state with an input of type patrol state enum. Next is get normalized speed with a float output. Then make one called get fish type with an output of fish type enum. Make one for getting fish species too. Next is set site type with an input of detected site priority enum. Make a similar one for set hear type with the detected hearing enum as the input instead. Then add one called set sleeping with a boolean input. Finally is get perception types with two outputs of AI perception type enum for sight and hear. Next I will make the master animation blueprint. Click on the template tab since we don't want to choose a specific skeleton so we can make it for any different type of fish. Go to the event graph and copy the code shown. This basically returns the speed of the fish as a normalized value between 0 and 2, with 0 being idle, 1 being regular swimming and 2 being sprint swimming. Now go to the anim graph. Add a new state machine graph called locomotion, then add a default slot to it before connecting it to the output pose. This will let us play montages if needed. Open the locomotion graph and add the swim blend space we made. Set the speed input of it to the speed variable. That is all for the animation blueprint. Now we can simply right-click on this master blueprint and create a child class of it with a dedicated skeleton so it is modular. I will make one for the koi and move it to the folder. Open it and you should see the asset override editor. You can see if I open the drop-downs, the blend space being used can be changed, so if I make another child class of the animation blueprint for a different fish skeleton such as a shark, I can simply set the shark's blend space here and it will work for it. Now we can start the fish blueprint. First make a folder for AI and make a new AI controller. Navigate to the CPath plugin folder again and find this example flying pawn. Copy it to your folder and rename it to something like Master Fish Actor. Open it and delete everything in the event graph. Make sure Auto Possess AI is set to placed in world or spawn so the fish spawner will work too. Then search for AI controller class and set it to the fish one we just made. Delete the default components and add a skeletal mesh instead. Set the mesh and anim class to the ones we made. Then add a capsule component under the mesh. Set the rotation and then the half height and radius so it is accurately around the fish for collision. Then set the collision preset to block all dynamic. Add an AI perception stimuli source like we did for the player. I will now modify and add all the variables that will be used so it is easier to work with them. Uncheck the eye icon for the variables that I do it for. Change smoothing passes to 0 for now. Set the path recheck rate to 0.1. Change the node distance tolerance to 100. I will put all these variables in a new folder. Copy the variables I add on screen and make sure to set the variable types correctly. I will also categorize them so it is easier to organize. This first set of variables will be customisables that can be changed per fish. Again, these variables will be described when used in the actual code. Set the default values as shown. They are values tested with this koi, so if your default is a similar sized or behaving fish, these values are a good starting point. Set the default value of fish static mesh to the one we made. These are all variables that you can change for different child classes and can be accessed easier since I put them under this category. The next two variables are for world references. Enable instance editable and expose on spawn for both of them so they can be set to references in the scene. I will add the fish to the pond. I can now set the sea path volume and patrol area references to the ones I added to the level earlier. Now I will add general variables that will be used for the code, but these should not be changed in the child classes. Now select the flying movement component, which is just the floating pond movement component renamed. Change the max speed to 200 and turning boost to 15. Then click Class Settings. In Implemented Interfaces, add the fish BPI we made. Open the Get Perception Type function and return the site and here perception type variables. Then do the Get Fish Species and Type functions, returning the corresponding variables. Open Get Normalized Speed and copy the code shown. This part of the code maps the speed from 0 to the default or sprint speed to be between 0 and 1 or 0 and 2 instead respectively. Next, open Get Patrol Position. Add a local variable first called Patrol Position. Copy the shown code. This part of the code finds a random position within the bounding box, however the trigger box might be rotated in the scene such as for my map, so we need to write some extra code to account for this. This is for random in bounding area where the target destination is just a random point within whole trigger box. We need to make a function now. First move the default ones to a new category. Make a new one called within landscape check with the shown inputs. Set the default values as shown. Add the following outputs too. Add a line trace by channel with the following setup. I will make the draw debug type a variable so I can debug it later if needed. Here we are checking if the hit actor was the landscape, which is why we added the tag to it earlier. Make sure it is exactly the same with case sensitivity. This code basically gets a point and checks whether it is within the landscape, since the random point is only bound by the trigger box but not the landscape. Most landscapes are bumpy, so a box will not perfectly be able to cover just the areas we need, so this function checks whether the point is below the landscape, and if yes, then adjusts the point. Make another function called setNearSurface. Add the shown inputs and outputs. Copy the code shown. Add a local variable called target location. This part checks if the point is near the water surface, which is set as the water level variable in the sea path volume, which I showed towards the start. Since we want to check if near the surface, we subtract a value here. Set this as was last point near surface. This function is used to keep the fish underwater and to set the variable when near the surface. It will be used later since we want the fish to swim on the surface with a weighted chance if previously just swam near the surface. Go back to get patrol position and continue copying the code. This now modifies the position to be within the landscape. Duplicate this calculation and change the first part. This is for the random in range, and the range is dictated by patrol radius. Copy the code. This checks if the last point was near the surface as I just mentioned, and if true there is a higher chance of the next point being at the surface again. Next, make a function called getAIBlackboard and copy the code. This simply returns the blackboard from the AI controller. Next, make one called find flea location. Add the shown inputs with the default values. Distance multiplier is a vector 2D, so we can give two floats to use for a random in range. Copy the shown code. Flea recheck is used as to recheck a new flea location if it failed. Set the max speed to the sprint speed since the fish should sprint if fleeing. This sets the target flee destination to a random position away from the actor trying to be fled from. This ensures the flee destination is clamped within the landscape. Make another function called collision strafe. We will use a box trace to check if the fish is swimming into anything. This function will strafe or move the fish around if an object is detected in front of it, so it is a bit more realistic. Now find the go to macro and rename it to go to location. Modify the existing code as shown. This is from the plugin, so I won't explain what the existing code does, but you can read through it if you want. We are adding on to the start and end positions here, since adding randomness gives a higher chance of a reachable point being found in the pathfinding grid. We will rotate the fish on tick, so remove the rotation code from here since it was a bit buggy with the approach I took to move the fish. This will try to redo the movement 25 times if it failed by using a random offset. If it still failed, it will try another 20 times to use a random position in the bounding box regardless of the patrol type. If still failed, it will just return as fail and reset for the next cycle. Connect this to the failed output. Now go to the event graph. Add event begin play. Copy the code shown. This timer can be used instead of event tick if you are wary about performance. It can be stopped temporarily if needed by clearing the timer. Make a custom event called onMovementFinished. This will reset values as shown. This rotator is used to rotate the fish back to facing relatively upright once a movement is finished. We will use a timeline to rotate the fish. Right-click to add new points to the timeline. You can also shift and left-click. The timeline simply goes from 0 to 1 over the duration, so we can interpolate the rotation. Next, make a custom event called Patrol. Copy the code shown. This randomly selects whether the fish sprints or not based on the customizable sprint chance value. A short delay is being added here to prevent bugs. Add a custom event here called Interrupt Patrol and connect it to Interrupt. Call onMovementFinished for both success and failed paths. In then 1, add a branch that sets timer by function name if draw debug path. Set the name exactly. This is for debugging the pathfinding path. Now open the AI controller. Open the full blueprint editor. Remove the default nodes. Make a custom event called Toggle Side Perception. We will fill this in later. Go back to the master fish actor and make a custom event called Player Interaction. Copy the code shown. This checks if the player is swimming, since the fish should only swim to them if they are in the water. If you didn't follow along the swimming, you can just skip this node. This calculation will set the target destination to be a bit away from the player in the same direction, since we don't want the fish to try to move to the actual origin of the scene actor. This will make the fish only follow if far away enough to the player currently. This toggle side perception is used to buffer the side perception, so there is some delay in which fish will try to move to the player. This sphere trace checks if the fish is already near the player and only moves if not. Also, it is important to mention here that this will only work for single player games, since I am using get player pawn and character, so it only actually checks against the controlled player. Likewise, it won't work with NPCs either, so you will have to adjust the code for that, but it should be a pretty simple change to just check for pawns in general. We will now do the flee path. Set the getAI blackboard function to a pure 1. This checks if not already fleeing. Since the noises will be heard usually from an actor making the noise, we can just use the actor location of the last heard actor. Here we increment the flee recheck count, which I explained in the find flee location function if it failed. Now add a custom event called react to noise. It will basically just use the code we wrote for the site interaction, since it will move and respond in the same way. Next is a custom event for sleeping. Copy the code. This code will be called repeatedly while sleeping. Here we are restoring the energy. You can change the multiplier value if you want, which currently restores twice as fast as it depletes. Wake threshold is a value that will be randomly generated so the fish don't all wake up exactly when it reaches 1. This is to add some natural randomness. Now add the event tick. You can add a custom event called fish tick, which is the alternative to event tick if you don't want to use it. If sleeping and the type is set to side, we will set the actor rotation so the fish is rotated on its side. This is an optional setting. Add input vector to the flying movement component using the current input vector, which actually moves the fish. If the normalized speed is above 0, we can set the rotation since the fish is moving. This code depletes energy with a multiplier based on the speed. If idle, it is half the default depletion rate. If swimming, it is the default, and if sprinting, then double. This sets the rotation if sleep type is set to side. The wake threshold is a random value between 0.9 and 1, but you can adjust this if you want. Add one more event here called interrupt sleep and copy the code. This is used to interrupt the fish when sleeping if a sound is heard. The energy is given a small boost, so if it needs to flee they can. It might not be the most realistic or best response to a sleeping fish to just give them extra energy, since it can prevent them from actually sleeping, but I couldn't think of any other way to do it. We will now do the interface events. First is set patrol state. Check if the blackboard is valid first, then set value as enum. Write the key names exactly as I do with case sensitivity for now, since it needs to match up with the behavior tree blackboard. You can change them later if you want. This custom event will be called repeatedly while the fish is moving. Add a timeline for the flutter functionality. Flutter will make the fish bob in a sine wave pattern so they don't swim in a straight line. Copy the timeline graph as I do, although you can change it up if you want, but the general pattern should be a zigzag like this. Since we want it to be smooth, set it to a user curve, then flatten the peaks. The flutter amount can be set to 0 if you don't want it, especially if the animation already has a fluttering motion. This makes the flutter timeline only play if it isn't, so it doesn't restart each time it's called. You can realistically use a looping timeline and start it once on movement then stop it on end, but this method is less prone to bugs. If there is any other functionality you want to give the fish while it is moving that should be called repeatedly, add it in the sequence here. An example is a pufferfish expanding and contracting. Now add the other events. It is similar code, so just copy the code shown. Make sure again to write the key names correctly. Event set sleeping needs some extra code. If sleeping is true, we need to stop and disable the movement. Also, the interrupt events are doing the exact same thing, but I made them separate events anyway so they can be given individual extra code later if needed for any reason. If sleep type was side, we need to restore the rotation, so we'll use a timeline for it. Finally, go to the get.toNode function, and as an is valid for the flying movement here, since when sleeping it is disabled. Next we will make the dead fish actor. We are using a separate actor for this since buoyancy will be used, and I wasn't able to find a way to dynamically set the pontoon points so different sized fishes can't be changed. Add a static mesh and make it the root. Set it to the default one we made at the start. Enable simulate physics as it is needed for buoyancy. Set the mass to 500 and both damping to 5 so it is more floaty like it is underwater. Next add a buoyancy component which is from the plugin. We need to add pontoons to make it float on the water surface. 4 should be enough for most. Use a temporary scene component to find the positions. There should be one in every corner of the fish. Adjust these values as shown. They will make the fish float more realistically. Add a variable called fish species and make it instance editable and expose on spawn. This will be used to keep track of the species since it is a separate actor. Now go to the master fish actor. Make a new variable of type dead fish actor class. Set the default value to the dead fish. Make a custom event called on death. Copy the code shown. This disables all AI and movement. This spawns a temporary mesh until the fish reaches the water surface. Make the following variable. This makes the fish rotate in a random direction. Add a timeline called fish rise and set it to looping so we can keep moving the fish up. This keeps the fish rotated when dead. We will use set near surface to find when the fish has reached the water surface. Then spawn the dead fish actor. Make sure to set the fish species variable. Finally call destroy actor since the dead fish actor is spawned now. We need to do quite a few bug fixes and extra additions now which I found from testing off camera. First is in go to location. Copy the code shown. This is used to ensure the fish remain submerged in the water. Go to this part. Change smoothing passes to 4. Then randomly select an integer between 0 and the smoothing passes variable. This is again because the pathfinding plugin can sometimes glitch with the code setup I have used, so randomizing as many things here increases the chance that a reachable path is found. The smoothing passes is actually important in how the path is determined, however, so I highly recommend reading through the documentation on it. Here is the explanation of it from it. Then at the end here, set patrolling to false before setting success since it finished. Next, go to the interaction events and call on movement finished after toggle side perception. For this next addition, go to the fish mesh. Add a socket near the head called head socket. Go to the onMoving event. Copy the code shown. This will stop the movement if the fish is only roaming with no interaction and it has reached the destination. It is a more direct approach in checking if the destination is reached. Values of 100 and 200 for the speeds also work better for a fish like koi, although again all of these can be changed to your liking. Next, go to the interaction code. Make the change shown. It does the exact same thing but uses the corresponding enum instead. Go to the patrol event. Make some space and add the shown code. This checks if currently waiting, and if not then does a do once, so the patrol cannot be reset by another patrol call unless we want it to. Now go to event tick. If you find the rotation to not be as accurate, you can try this different approach instead. This gets the rotation to the actual individual point in the pathfinding grid. Now go to the flee code. Remove this part as it isn't needed. This will let the flea be called 20 times until succeeded before it is set as failed. Open find flea location and call on movement finished in this branch is false. Then make the following adjustments to the calculation. This code tries to find a more accurate flea location by finding it opposite to the direction the noise came from. However, since it might fail due to obstacles or any other reason, only half of the rechecks calculates it from this direction, while the other half is a random direction. Finally, modify interrupt flea as shown. In this branch, add the code if you have the submarine systems done. This is so they can be detected if the player wasn't swimming. Go to get patrol position and replace this with the water level since it might not always be 0. Now in begin play, add this branch that continues the rest of the code only if the sea path volume and patrol area references are set. If not, then we can disable tick and the AI controller. Finally, open the dead fish actor and in the mesh, set lock rotation to true on all 3 axes. Change the pontoon radiuses to something smaller like 20 since this is a small fish. Now we will work on the AI controller. First, add an AI perception component. This is for close range sight. Copy the settings on the right. Make sure to set detect neutrals and friendlies to true as it won't detect otherwise. You can change the values of the radius if you want. Uncheck starts enabled too. Duplicate it twice for medium and far. We are using 3 different ones since I couldn't find a way to change the sight radius in script. Then add a new one for hearing close range. Make sure to set the dominant sense and added sense to the hearing one this time. Again, duplicate it twice for medium and far. Now add event on possess, which is basically begin play for AI, which runs when a pawn uses this controller. Promote the pawn to a variable so we can access it later. Since we used a blueprint interface, we don't need to cast or access the master fish blueprint directly. Copy the shown code. This code enables one of the 3 sight senses based on the selected range, which is a customizable variable in the master fish actor. Do the same for hearing. Next, make a function called find sight priority. Add the shown input and output. Make sure it is an actor array input. Make a new variable called last seen actor. Copy the shown code. This checks whether the fish detected another fish and if it is both a predator and it is higher up in the food chain based on the species enum we made. If true, set the detected type local variable to predator. This breaks the for loop since predator fish should have higher priority, so we don't even need to check for the player or any other sites after that. This checks if the player was detected and whether player interaction is enabled. We are hard casting here to the master fish actor, but I thought it would be pointless to make a whole interface function just to return one customizable variable since We will now do these bind events. Add and copy the following custom events. This checks if the actors in view of the fish are greater than 1, and if true we need to use the side priority function. If false, we can just use an array with the single value since only one actor was detected, but we still need to check if it is a predator or player or something else. This sets the side type to none if nothing was detected anytime the side perception is updated. Now we will do the hearing events. This sets the hear type if it is not empty. This sets the last heard actor, and we are hard casting again here, but you can use new interface functions for it if you want. Next we will fill in the toggle side perception event. Copy the shown code. This simply disables the side perception temporarily before enabling it again, which is for bug prevention. Now make a behavior tree. In the AI controller, at the end of begin play, add a run behavior tree, selecting the one you just made. Currently we can't remove the perceptions if we don't want them. Open the AI perception type enum and add a new option called none. You can change the AI perception in the fish blueprint to none to disable them. Modify toggle side perception too. Finally, in the master fish actor, open the find flea location function and add the within landscape check at the end of it. Go back to the AI controller and add a short retriggerable delay here. We will now do the behavior tree. Make a new blackboard for it first. I will try to explain this as much as possible, but please comment if you have any questions. Blackboards are basically used to let the behavior tree read variables which are modified in the blueprints so it actually functions. Add the following keys. This is just variables essentially. To select a particular enum, open the key type drop-down. Make sure to select them correctly as I do. Made a typo here, so we'll quickly change it. Now open your behavior tree. Make sure the blackboard asset is set. You can switch to the blackboard directly from here, so you can close the other tab. Make a new folder called tasks. This is custom written code we can run in the behavior tree by calling it. Add a new blueprint class and search for BT task. This will be the fish follow actor task. Click on function override and add event receive execute AI. Make sure it is named exactly as the blackboard key. Copy the code shown. Finish execute is called when we want to mark the execution as completed in the tree, and it can continue the next cycle. This order makes it so that if nothing is in sight, It checks for hearing since sight should have higher priority. Duplicate and rename it to fish moving task. Change the code as shown. This calls the onMoving event we added in the master fish actor. Next, duplicate fish follow actor and call it fish react to noise. This is exactly the same as follow, but you can change it up if there is features you want exclusive to noise reaction. Duplicate the moving task and rename it roam. Change the event to patrol. Make another one called fish sleeping and change the event to sleeping. That is all the tasks needed. Go back to the behavior tree. Drag out of the root and add a selector. This is kind of like a nested branch where it will select a path based on the met condition. Drag out of this and add the fish sleeping task. Right-click this task and in Add Decorator, add the blackboard option. This is how we set the conditions. Change the key to sleeping so it will run this task if the sleeping task is true. Drag out of the selector and add a sequence now. Add a selector to this. Then add the fish follow actor task. Add the following decorators to it. This makes the fish follow if it has seen something and not currently fleeing. Copy the rest of the graph as shown. Set this decorator's observer aborts to self, which basically stops this flow if this particular condition is not met. This will call fish react to noise if heard, not currently fleeing and nothing is in sight. Also, behavior trees will run in order of their placement in order of left to right. They have numbers on the top right of the order. This next one is removed after, so I will speed it up. This will call fish moving if currently roaming and nothing is seen. Add a sequencer after these. Add the wait node. Set the wait time to something like 1.5 with a random deviation of 1.5, so it will be a random value between 0 and 3. You can adjust these values if you want. Add the shown decorators to the wait too. This interrupts the wait if something is seen or needs to flee. Finally call the fish roam task, so after waiting it will try to patrol. Reset the observer aborts for the decorators in fish moving. Add one more decorator to the weight as shown. Then duplicate the fish moving task and make the only condition if patrol state is equal to roaming. That is all for the behavior tree. Finally, in the master fish actor, go to the onMoving event and add the following code. This was to fix the fleeing getting stuck. I did the bubble system off camera since it uses a particle from previous videos in the series which I made in the swimming tutorial. The setup is the same as how I spawned bubbles in the boat videos. Here I am spawning the bubbles with a delay when go to location is called in the tail socket, which is why we added that socket at the start. The main fish AI is now done. If you press G in game you can debug the pathfinding grid. The green squares are where they can travel to while red can't be, such as here since it is being blocked by objects. Also the grid should not be that tall and should stop at the surface. To fix this, change the octree depth back to 2. I will now showcase the main features. Here is the default fish with the default settings. You can see the behavior tree on the right and how the logic flows work. When the fish sees the player it followed those paths and interrupted the current one. Here is the visualization of the patrol points being selected. You can see the fish fluttering as well. Here the fish follows a herd noise, then detects the player by sight, so follows them. You can see once the fish reaches the player, it waits and then swims away instead of just staying with them. Here is the fish fleeing. You can see the fish swims away faster when it sees the player. Here is the fish sleeping. It will call that task while sleeping repeatedly, so the energy is restored using the blueprint event we made. Here is the fish death. It is currently toggled by an input for showcase purposes, but it can be called whenever you want the fish to die. The fish rises up slowly and once it reaches the surface it is replaced by the dead fish actor, so it has the buoyancy. Here is the pathfinding working to make the fish reach its location with accurate detection. There is a wall in the middle of this pond, and if the target location is on the other side of it, the pathfinding will find a path around the wall. If we just used a regular approach such as the move directly to node in behavior trees, the fish will just collide with this wall and not be able to reach the destination. This is the main reason why this plugin was used, since different maps might have obstacles around it, or for example in a seabed map with a lot of rocks or shipwreck. You can also visualize the AI with Unreal's debugger, which you can enable by pressing the apostrophe button. Pressing 4 on the numpad will show the perceptions. When I go in the fish's range, you can see a debug drawn on the player since the fish can see me now. Here is the submarine interaction. Basically much works like how the player interaction does. I wrote some extra code for this, however off camera, since the fish needs to stop in front of the submarine and the random value we gave will not represent all submarines as some are much larger and longer. You can manually place fish if you want by duplicating them like this. It works perfectly with this many fish too. However, if you want a large number of fish, doing it manually will not be the best way, so I will now show how to create a fish spawner, which is the last part of the tutorial. Make a new actor. Add a box collision. You can use a different shape if you want, but box is the most flexible. Make the shown variables. Set these all to instance editable so they can be changed in the editor. Now go to the construction script and set the box's box extent to spawn range. Now we can set the range of it per actor in the level. Add event begin play and copy the code. We subtract 1 from the no of fish since the for loop starts from 0. Copy this code from get patrol position in the master fish actor. Hold Ctrl and drag the pins to replace the connections like I am. This finds a random position in the spawn area to spawn the fish at. This sphere trace is used to check that the spawn location is empty space. If false, spawn the fish actor at the location. This will choose a random rotation so the fish don't all face the same way when spawned. If this branch is true, we will try to find a new position to spawn. There is no limit to this, however, so you might want to clamp the number of times it can recheck. We need to add the within landscape function here too, so I will quickly move it from the master fish actor to a global function library I have. I will speed this part up since it's not new code. Add it as shown in the fish spawner actor. Change the up offset to something smaller like 25. Select the box collision and set the collision to no collision since it was interfering with the pathfinding, and we don't actually need collision for this since we just need the extent. Finally, in the master fish actor, select the capsule. Change the collision to custom and change the visibility channel to ignore. That is all. Add it to the world and again make it encompass the area like the sea path volume and patrol area. You can now choose which fish to spawn, the number, and make sure to set the sea path volume and patrol area references. You can see the fish now spawned in using the spawner, and it works just the same. This is for a small pond, so I will quickly show it in a larger ocean map. I will copy the 3 actors and paste it in the seabed map, which has a lot more open space but objects on the floor. First I will increase the sizes of them so they are in a larger cube shape. I will increase the fish amount to 50 and set the references again. Now select the sea path volume. Change the octree depth to 3 since this is a large open space and the cube isn't actually overlapping much of the meshes here, but it will still work regardless. You can play around with the voxel size as well, although it may affect performance especially at lower values. That is all. Here is the pathfinding grid. The fish is working as expected. You can see the squares are red here where it overlaps with the seabed. Also, sometimes it might be useful to make the sea path volume a bit bigger than the patrol area, so even if the destination is close to the edge of the box, there is extra squares around it for the pathfinding to work. That is all for the fish spawner. The final quick part of this video shows how to add other fish using the master blueprint. I will use this bull trout by this user on Sketchfab. I already imported the model. Open the mesh and add the tail and head sockets. Next, make the blend space like we did for the original. Now make another child class of the master fish animation blueprint, selecting the new fish skeleton. Open it, and here you can change the blend space being used to the new one. Next, make a child actor of the dead fish actor. Make a static mesh using the skeletal for the new fish. Open it and add 26 DOP collision. Set the dead fish's mesh to the new one. Adjust the pontoon positions if needed. This trout is longer than the koi, so I will update the pontoons. Next, create a child actor of the master fish and name it to the new fish. Change the skeletal mesh and animation blueprint to the new ones. Update the capsule collision size too if needed. Now in the fish settings, change the fish species. Then change the static mesh and dead fish actor. You can then modify the other settings to your liking, such as the speed and interaction types. I will use the fish spawner to spawn this new fish. You can see it works perfectly, and there are 5 koi and 5 trouts now, and the behavior works the same. You can add any type of fish you want, although larger fish will require some fine-tuning. A whale is included in the project files as an example. That is all for this video. If you enjoyed, like and subscribe for more content. You can purchase this final result from Gumroad using the link in the description if you want, which will contain the upcoming predator fish as well as one package. The project files will include exclusive features which include random textures, colors, and hue, Ragdoll and other extra death options, Whitefish, Dace, Trouts with 3 variants, Tuna, Manta Rays, Seals, squid that can shoot ink, whales that will surface and shoot water when they need to breathe, and more fish spawner settings. The project files also come with the realistic island example, including a night scene. The swimming and oxygen system is also included. Thanks for watching.